So, Jörg, please take it away and thank you very much.
Yeah, hello everyone. Probably at home as I am. Well, I hope my neighbors won't put too much strain on our internet connection, so it will be stable. If there is a delay or something doesn't show up, just give me a shout so I can be a bit slower, or if you don't understand me anymore. With me are my colleagues Gabi Dröge of the GGBN network and David Fichtmüller of ABCD. And they will be having a look at the chat. So as Erika mentioned, we will have three question and answer sections. But if you have any questions while I explain things, just put it in the chat and Gabi and David will try to answer it straight away, so it doesn't keep you from understanding the rest of it. This today is a follow-up to the webinar about BioCASe about a month ago. So it doesn't require any IT knowledge to follow, but you should be aware of the basic ideas of BioCASe and the ABCD standard. So if you haven't worked with BioCASe and also not seen the last webinar, it might be a good idea to watch the recording first and then watch this webinar, because I will build on that. Can you see the slides now, the second one? Okay.
Yes.
Yeah, the first one is the link to the past webinars, but I guess it's the same as the one in the chat, where you can get or see the recording of the first BioCASe webinar. And everything I will show can also be found on the documentation page of the BioCASe provider software. That's the second URL. So I will be doing step-by-step explanations to certain things, and the same can be found on the documentation website. So there's a guide, step-by-step guide to installation, to installing, to configuring BioCASe, and also to testing and debugging. The ones who attended the last webinar will know this slide, that these are the three steps you need to take if you wanted to use BioCASe. Of course, install it on one of your servers, then do the mapping, connect it to your collection database, and then do the testing and send out the URL to GBIF, for example, if you want to share your data with GBIF. And I will do small presentation of small demos on these three things. I will, in the first part, I will install BioCASe from a Docker image on one of our servers. Using Docker is the fastest way to install BioCASe. Then in the second step, I will connect it to a small sample database and create a mapping to ABCD2. This will be a very, very basic mapping. And then in the third step, we will have a look at this web service, at this data source we just created in the second step, and we'll see what ABCD documents really look like. Yeah, that's it for the slides. So no more slides. And we're going to go on with the first part, which is the installation. So are you able to read this? Is it large enough for everyone? David?
You could type a plus in the chat if you think it needs to be bigger for your screen.
Okay, just think it's okay.
Looks like everybody's okay with it.
Okay. Well, BioCASe, what I'm going to show, this is one of our servers at the Botanic Museum. It has nothing installed, no web server, no Python, no BioCASe, just a pure Docker installation. Just one small command. Of course, you could install BioCASe the traditional way. That means you install the the required packages, that is the Python language, because BioCASe is written in Python, Java, then a web server, and maybe even more packages you need for connecting to a certain database management system. But with Docker, that's all one step. So you can compare it to the installation files you know from Windows installers. Python is about the same. So everything, the software itself and all required packages can be installed from one image, and they will be stored in one, it's called a container. So it's isolated from everything else on the server. This is very easy to install, very, very fast, and the advantage also very easy to update and to get rid of. So if you don't want to use BioCASe anymore, it's very easy. You just remove the container and everything connected with BioCASe will be gone. So this is what you see is the terminal window to the server. I'm going to show the first thing, because I'm going to install software, I need some privileges for doing that. So I will tentatively get user access root rights to the server. Yeah, I forgot to say, installing BioCASe is probably something that the IT people will do for you. But with Docker, it's very easy. So if you're a bit tech savvy, that's something you can do on your own. So that's why I'm showing it. So now I have root privileges on the server. And the first thing I'm going to do is check the version of Docker. The thing is that BioCASe uses Docker hosted volumes, and they've been introduced in version 17. And therefore you need at least version 17 of Docker, and you can check this with Docker version very easily. So in this case, it's version 18, so we're safe to run BioCASe. In a second step, I'm going to download a makefile that is basically a very small text file that acts like a setup script. It tells the installer where to find the BioCASe image, which steps need to be done to install it, how it can be stopped and removed later. So I'm gonna get the URL or this setup script from the wiki that I mentioned. So this is the documentation of BioCASe, and one of the guides you will find is the installation. It is a very long document because it also documents the traditional way of installing BioCASe, web server, Python, and so on. But the Docker description is rather slow. And the second step, you will find the link to this makefile. I just copy the link, get back to terminal, and then use wget to get this file. It's very small. So this has been downloaded now to the local file system of the server. And running the install, you can just use this makefile by just typing in make install. So this make software, it's a deployment software, will use this installation script, download BioCASe, install it, and even start it. So this was very fast because I have to admit I installed BioCASe before on the server. Usually it takes about something between 10 seconds and 1 minute to download this image and install it as a container. Because I did it before, you can read that it was written that the image is up to date. If not, it would have been downloaded. Yeah, takes about a minute. Then the BioCASe software has been extracted, put into a container, and started up. So actually, that's it for installing the software itself. BioCASe basically is a web service, so that's what once you've installed and configured it, will be run what will be used by GBIF to get access to your data. But it also comes with a small interface that can be used in the web browser. And with this interface, you can configure the software, add the mapping to your local connection, to your collection database, and also test it. And we're gonna just have a look at this interface or see if the interface comes up in the browser to make sure that the installation was completed. So to go to get to this interface, you just need to type in either the name of the server you installed BioCASe or the IP address. In this case, because it's just a test server, I can use just the IP address. And then the default path where BioCASe installed is BioCASe. Of course, you can change that. So if you decide to use BioCASe as a subdomain of your website, you can also change that. So this is the default, and you see this interface is coming up. We will have a look at it in the second and the third part of the webinar, but it comes up, and this means that the installation has been completed and, well, went right. Back to the terminal window. This make script that we just used to install BioCASe can also be used to remove it if you decide not to use BioCASe anymore. I won't do that now because we will need the installation later on in the second part. But something that might be useful too is to update BioCASe to the latest version. So to do that, you would simply type BioCASe update. What this will do is just stop the BioCASe server, remove the container, download a new image, and reinstall a new container with the latest image. If I do it now, nothing will happen, but you will see that, yeah, it's doing exactly what I said, stopping BioCASe, removing it, then downloading the latest image, which is the same as we already have, and reinstall it. And if we go back to the interface, it should still be running, yes. So with this Docker virtualization software and the makefile, it's very easy to install and remove and update BioCASe. One thing to keep in mind that it always just touches the BioCASe software itself and not the configuration. Something that is kept separate from the container is the configuration. As you will see later, configuring BioCASe, it means connecting it to your collection database and creating the mapping between ABCD and your database can be time consuming and will, yeah, also will take some time until there's no error in that mapping. So as soon as you finish that, you should try to, or you should always create a backup of that configuration. And that's also the reason that this configuration is not removed if you remove BioCASe. It's just a bunch of XML files, so it's not taking up much space. But this is the result of your configuration work. So this will be never lost if you remove BioCASe. I'm going to show you where these configuration files are located. As I mentioned, they're saved or they're done using so-called Docker hosted volumes. So that's a mapping to a special location in the local file system of your server. It differs a bit, or it could differ on the different operating system where exactly that is located. You can always refer to the Docker documentation to find where that exact location is. On Linux-like systems, and this one is Debian, this is always the folder var lib docker volumes. So I'm going to change to that folder, and if you just do a listing of the folder, you will see there are 4 subfolders. One is BPS, BioCASe Provider Software Configuration. That's where all the configuration is stored. That is the individual data sources and the mappings to the collection databases. BPS log is where the logging files are located. So if you experience any problems or questions when you configure BioCASe and you get or you write a mail to us, we will very ask you to have a look at those log files or send us the log files so we can find out what's going on. This is the place to find it. And coming back to the backups, as soon as you've finished configuring BioCASe and everything is as you expect it to be, then you should always back up this configuration folder. Not the BioCASe software itself, the container. That's something you can easily reinstall from the image, but make sure to back up this configuration folder of BioCASe. That's it for the installation part of BioCASe. So it wasn't that much, but I just wanted to show that it's with Docker, it's rather easy to install BioCASe. It's not that complicated anymore. Are there any questions on that?
And if you'd like to ask any questions, you're also welcome to unmute yourself to do so at this time, or do so in the chat.
I have one while we wait for the how do you provide help? People run into problems. How do you provide help with the installation? I mean,
yeah, you can just if you look on the documentation, you will just have a form where you can write an email to us, or you can directly write an email to BioCASe, support@biocase.org, or you can, well, if you look at the BioCASe page of the BGBM, you will find our telephone number. You can even call us. So just get in contact with us and we'll get back to you. Since this configuration interface of BioCASe is all web-based, web browser-based, as soon as you've installed it, we can log into your installation and, well, give you direct help with a precise mapping with a data source, for example. So we might be able to assist you even in the mapping process itself. Does that help?
yep, thanks.
And it seems like maybe that section was didn't have too many questions. So if anyone thinks of anything, feel free to type questions in the chat as you think of it. And when we get to the next breaking point, Jörg can address them. Yeah, so now what we see is the BioCASe installation we just set up. What we're going to do in the second part is to create a new data source for a small sample data source, connect it to a database, and then do a very, very basic mapping to ABCD2. Setting up a data source is basically setting up a new web service. So later on, we will this data source will get a known URL, and we will send this URL once everything is properly configured to GBIF, for example, and GBIF will use this data source in order to harvest the data and get access to the data you want to publish. So a data source in BioCASe terminology is actually a web service. So what we see here is the interface. You can use it to configure BioCASe, to create new data sources. And you have some tools to query your data, to test it, to have a look at what it looks like. That means what data after the mapping is finished will be sent off to GBIF. So the first thing we have to do is to create a new data source, that is a new web service. For this, we go to the configuration tool. That is the system administration. This allows setting several or changing several settings of BioCASe, and also to create a new data source. So yeah, that's something I forgot to tell. As soon as you've installed BioCASe, you should change the password of the BioCASe configuration tool, because otherwise, as soon as the installation is public, and everyone could log into and change the configuration. The default password is ACDC, easy to remember, but as soon as you finish installation, you should change it. Is that large enough? Just to make sure that everyone can read it. Make it bigger.
Looks like people think that's good.
Yeah. So as I mentioned, you can use this configuration tool to change certain settings. I won't go into the details of that, but what we will do is create a new data source. So we go to the data sources section, type in the name of the new data source. I call it BioCASe demo. We leave the template as empty because we want to create the mapping from scratch on our own, and push create DSA. And then we see that we've just created a new data source. And by clicking on that, we'll get to the configuration section of this data source. Now, this is all we see now. It helps us to configure this very access point we've just created by BioCASe demo. So there will be, actually three steps to configure it. First, we need to connect it to our collection database. That means telling it where the database is located, on which server, what's the database name, and so on. Then in the second step, we will tell BioCASe a bit about the database structure, that is, which tables or which views we want to use to publish the data. And then in the third step, we will create a schema mapping, that is, draw the connection between the ABCD standard, which is used to publish the data, and the tables and views in our collection database. So the first thing is setting up the BioCASe connection, the database connection. As I mentioned, this is just telling BioCASe where to find the database. First, you have to tell which database management system is used. MySQL is the standard, we leave it. Then just type in the name or the IP address of the server. That's the IP address of our MySQL server at the BGBM. Then the name of the database. It's called the same as I've chosen the name for the data source, and then the user. Concerning the user, there's one recommendation, because BioCASe just reads data from the from the database. It will never try to alter data or modify it, and therefore we recommend to always create a user that has just read privileges to the data you want to publish. In this case, I've created one called web user, and this has just read privileges. So it's safe if you run into, or if BioCASe has some security issues or Python. If the server gets hacked, your source data or your collection data cannot be altered by using this user. So I click save, and as you can see on top, the connection works. And that's it for that part. The next part is telling BioCASe a bit about the table structure, or the database structure of your collection database. Usually collection management systems have a lot of tables and views. You just need to inform BioCASe of the ones that you want to use, or that you have data, or that hold data that you want to publish. So this will be either just a few tables, or what you also can do, you could create views that combine data from the tables you want to publish, and you would just use the views you've created for publishing in this database structure. So this is the first way of shielding your collection database from being published. Only the things, the tables or the views you sort of configure here in the database structure will be visible to BioCASe and to the outside world. In this sample, I will configure just two very simple tables, one for the specimens, where each specimen is one row in the table, and then I have one table for the metadata, that is for information on the whole data set altogether. And yeah, that's it for the second part. So we will just add these two tables in this overview. The table view column just lists all the tables and views that can be found in the collection database. For now, I will choose the specimen table and then click add. The alias thing is a bit, or is a way of separating the mapping that we will do in the third step from names and views in the collection database. So if you later decide to replace a table with a view, for example, because you want to convert data or blur some data because they're sensitive, then you can just replace a table with a view in this table setup and keep the mapping not modified. So this sort of decouples the mapping later from actual names of views and tables in the collection database. So that's the specimen was the first table, then the second one was metadata. So they've both been added. On top, you will see a small graph of the table structure so far. In addition to just telling BioCASe about the tables, you will need to tell it about the primary keys. In this case, it's very straightforward. They're both integers. And in the last step, if these tables are connected to each other with foreign keys, you will also need to add this to this table setup. So in our example, the metadata table is linked to the specimen table through a foreign key, and I can just tell BioCASe about this foreign key in this table setup too. So I'll link the specimen table to the metadata table by just adding a link to the table first, and then choosing the column with the foreign key. And this graph up here helps you a bit to see if things, well, if you chose the right connections and they chose the right foreign keys. So if you have more tables, the view down here in the lower part of the screen gets a bit crowded, and this table graph up there helps you, well, to get an overview of what you've just configured, and if that fits what the relations actually are. So for the example, that's it. Just two tables linked with one foreign key. Don't forget to save. And then we can get back to the overview page. to create the schema mapping. BioCASe is agnostic of a schema, so it can be used with several schemas. So you can connect, or you can map your database to several schemas, but for now, or in most cases, it will be the ABCD standard you use, or one of the ABCD extensions like GGBN or EFG. So for now, we'll create a mapping for ABCD2. Just select the schema, press create, and then we will get to the mapping editor. This now will allow us to link each element of the ABCD data standard, each element, to one column in one table of view in the collection database, so that BioCASe can load the data from the database and fill in the respective fields in ABCD. The first thing we have to set is the so-called root table. This is the table that holds the individual records we want to publish. In this case, it's specimens we want to publish. So I'll choose the specimen table as a root table. Down here, you will see, or you see, the structure of an ABCD document. So if you remember the first webinar, you have this ABCD structure of data sets and then metadata, which is the data on all the whole data set. And in the units part, you will have the individual records you want to publish, either specimens or observations. This is a rather small tree you see now because it's only the mandatory fields of ABCD. That's why they're put in red. So if you want to get valid, or if you want to get ABCD documents at all, these are the fields that need to be filled. Otherwise, BioCASe won't be able to construct valid ABCD documents, and you won't get any data out of it. So these 8 elements are the ones you need to map to column first, column that is filled with values. So this is sort of the first step you have to do to ensure that you get ABCD documents at all. So we'll map these 8 fields for a beginning. So let's start with the title of the data set. If you click on the plus column, you will get a small window that allows you to select the table and the column for this field. So if you go on the table selector, you will see the tables that you've set up in the second step, in the table setup step. And if you remember what I said about the aliases, that's where they come in. So here you will see the alias and not the physical name of tables of use in the database. So if you change the names of the underlying tables of use, you won't need to change the mapping itself. So for the title of the data set, it's not in specimen, it's of course in the metadata table, and the field is dataset title. The data type I can leave as text, and if I click on it, it will show up as a mapping to this ABCD field and will be printed in green. So that means a mandatory field that is filled. The next one will be the language tag, which just tells what's the language or in which language this title and description is given. And another option of providing data is, instead of linking it to a database table or column, you can type in a literal. So if you have values that you don't want to put into into separate columns in the collection database, you can just type it in here. If they're the same for the whole data set, and they will be linked as a literal. So these two options exist for linking, for mapping data. Either you can link it to a column, or you can map it as a literal. I will do the same now for the other fields. So the metadata content contact name, the technical content name, the modification date, that's a date. So that's the 5 metadata fields. And then there are 3 identifiers that I need to map. This is the triple ID you know from Darwin Core. So source ID refers, or is the same as the Darwin Core collection code. So that's something we've also stored in the metadata table. Source ID. Source institution ID is the institution code in Darwin Core. And the unit ID is the catalog number in Darwin Core terminology. So that's something that is in the specimen table. So now you've seen all the mandatory fields are green. So this is the minimum mapping I need for ABCD, but so far we haven't mapped any real information yet. So we've just mapped some metadata and identifiers. So as a last thing, we're gonna add some real information. That is the collector name. And for this, we need to first find the ABCD concept for this. And you can now view the whole ABCD tree, that means all ABCD concepts, by selecting this Show All Concepts checkbox at the top of the mapping interface. And this will now give you the whole ABCD tree. As you remember, ABCD is rather complex. It has about 980 elements. So it is quite difficult sometimes to find the right concepts, but in this step, also the guides on the documentation will help you. So there are overviews of frequently asked or frequently required ABCD fields, of fields, well, if you're aware of, if you know the Darwin Core fields, they will, these guides will help you to find the ABCD fields for that. So we wanted to add the mapping for the collector, an ABCD that's in the gathering tree, because ABCD has origin in the specimen community. Then it's the agents, gathering agent, person, full name. So we'll map this to the specimen collector. And when we're at it, we just add the collection date, the ISO date. So we map it to the specimen collecting date. Press save. And if we now uncheck this box, you will see all mapped ABCD fields. So these are the fields, the ABCD fields that will be filled in the resulting ABCD documents. And in the third step, we will see what it looks with real data. So if we go back to overview, you will also see that there are 10 concepts, ABCD fields mapped out of the 980 that are existent in ABCD. I'm now going to do the trick that you know from cooking shows, where they always come up with something they've prepared in advance, because mapping all fields or all elements for this sample database would take too long. I'll just open up another tab for our installation. And this is the data source we just created, a BioCASe demo. And demo is a data source that comes with BioCASe. So if you install it, there's already a small sample collection database part of the installation, and also a small data source with a full mapping. So we will have a look at this demo data source, which is already connected to the collection database, and this is the same data as the one we just used. So the full table structure has 19 tables. We're just going to have a small look what it looks like if you have more than just one tables. You see at the center again the specimen table that we've mapped and the metadata table, and a lot more tables that hold data on taxa. They just refer to the taxons identified on the locality side, and yeah, and so on. So the usual way of storing data is by normalizing things into several tables, and BioCASe, by telling these relations to BioCASe is able to reconstruct the data and load the data from the different tables. Back to the overview, and the mapping for this small sample collection database has 36 concepts mapped of ABCD. So some more metadata added, and of course more data on the specimens itself. So for example, the identification, the taxon name. This is the taxon name. Then some higher taxa, and of course some more information on the gathering side. So this is what a full mapping would look like. And in the third part, we will show how this can be tested. So we will send a query to this data source and see what the ABCD documents returned will look like. Are there any questions on this mapping? I know it was fast. No questions? Deb, I can't hear you.
No, I'm good. I'm good.
Okay.
That was fun. Thank you.
We are at the 10 minutes left mark. Do we still have one more section to go?
Yes, we have one. I'll try to hurry.
Yeah, let's do it.
This is the exciting part that I wanted.
Yeah. Well, now that we've configured this, we will have a look at what it looks like. So what the results look like. So what the ABCD documents that are constructed by BioCASe and sent to GBIF look like. For this, we're gonna use a small. So I'm going back to the first data source that we've mapped together. this, we call it query form. It's just a very, very simple page that allows you to send a request to this web service that we've just created and to review the documents that are sent back. So the URL on top is actually the URL of the web service. So that's the access point, the URL you will send to GBIF later. And when you ask GBIF to index the data, to harvest the data. The text box below can be used to fill in the request, the BioCASe request. And below you will find templates for typical BioCASe requests. So I won't get into the details of the requests. Just since we mapped ABCD2, we're going to we're going to issue an ABCD2 search request. This means that we ask the web service to send us back full ABCD documents. I'm going to remove the filter for now because we haven't created, so in this first mapping, we haven't created any mappings for these fields. So I remove the filter and just click submit. So this page will send the request to very basic ABCD document looks like. We have some metadata, the 5 fields that we've mapped. And then if we go down to the units part, you remember we have the 3 IDs, the institution ID, source ID, the unit ID mapped, and then just the gathering agent and the gathering date. And because we haven't mapped more than these fields, we only see these fields in the ABCD documents. So let's do the same with the out-of-the-box data source that has a fully functional mapping. So we go to the query form, do this ABCD search, click submit, and have a look at the ABCD documents. And in this case, we have a bit more metadata fields filled in. And if we go down, well, we have the full ABCD records. That is the identification result, the taxon name, the higher taxonomy filled in. Then more details on the gathering side. And then the record basis. All the stuff you know from Darwin core fields. So just to hurry up, the fun part, one of the questions was how BioCASe can be used to query or to filter requests. So part of this BioCASe request is the filter section, where you can create filters on any ABCD concept that you've mapped. So this template already contains a filter on this full scientific name, that is the taxon name. So what this eventually does is, or BioCASe will translate this ABCD, this BioCASe filter into a SQL filter. So you can use these filters to on all the ABCD concepts you map. You just have to specify the operator. In this case, it's like, so it's a pattern search, and the filter criterion. So, for example, if you want to get back from the web service just the specimens with of the genus Salvia, we just put in the pattern like this. This has already been filled in by the template. This is the full XPath of the taxon name in ABCD. Then hit submit, and we should get back only records Salvia. And if we scroll down slow, yeah, if we look at the taxon name, it's Salvia caprica. The next one, yeah, is another one. So this is a way of adding filters to BioCASe requests. And I mentioned that you can create filters on all ABCD concepts that you've mapped. You have a list of operators you can use. So you can use equals, not equals, less than, greater than, all the operators you know from SQL statements. And you can also combine different different expressions. So you can use and, or, is null, is not null, to create complex filters like you could do in a SQL statement. And I think that that was the thing that you wanted to know about that, right?
Understand how this could help people. So if you think about trying to check your data before you share it, it's often either in your database in rows and columns that you can get out in something like a CSV, but not everybody has a sort of SQL-like access to their data that allows them to sort of look at it in a way that they could check, oh, is that mapping right? Or did the dates come out in the format I expected? Or
yep, I can.
Yeah.
It's probably something else I might show. This search request always creates full ABCD documents. If you want to the values in certain ABCD fields, BioCASe offers another type of request called scan request. So this allows you to list all the values in a certain ABCD field. So it looks very much the same. So you have to specify the name of the X path of the field you want to list. Then again, you can create a filter. We'll remove that for now. And in this case, the concept that I'm requesting is the taxon name again. So this will list all distinct values of this taxon column, of this taxon name ABCD field. So this helps people to get a closer look on the data, the fields, the values that are in the certain ABCD fields, and check if they're right. So this is a list of all taxon names in the collection database. And you could do the same with the collection dates, with the country names, with the country codes for whatever ABCD concept you've mapped.
That's lovely. I mean, it's a really always nice to be able to sort of, for those of you who are more familiar with things like pivot tables, right? Be able to see your data in new ways. And if you had to try to do that by exporting that out of your database and then doing some magic in a spreadsheet or something, but this way your data can be queried where it is, so to speak.
Yeah.
Very nice.
I'd like to just, I'm going to jump in here for 1 sec, just because we're nearing the end of the hour.
Can I just tell one last thing on this
thing? I was going to, okay.
Because what's important to know about this, as soon as you finish the mapping and created the mapping and the installation is public, the access point you see here might be public. So all the data you've mapped to ABCD might be publicly accessible. So this is something to keep in mind. So if your installation is public, so that is the service publicly available, all the data you've mapped becomes publicly accessible and can be viewed by people. So it's always important to think about sensitive data, for example, exact coordinates, locations of rare species. And one way to deal with that is to maybe just don't map the exact location, the coordinates at all, or to not provide them for certain records. So if you have a data set where only a few observations should be hidden, or the locations of few observations should be hidden, you would probably create a view that blurs or just sets nulls those the locations of these rare species. So you will map these this view to BioCASe, and BioCASe won't be able to show or to export or to publish the locations of these endangered species. So that's something you need to think about before you map these sensitive data to ABCD and publish them with BioCASe. Because I remember that was one of the feedback questions on the first webinars, how to deal with sensitive data.
Yes, thank you. I think that's a question for a lot of people. I just wanted to ask if you have, do you have a few minutes, Jörg, if people do have questions and want to stay to ask? Yeah. Okay. So anybody who has questions, feel free to unmute yourself and ask, or ask them in the chat. This has been a really great demo. Thank you.
Thanks.
We did have, Paula was asking about ABCD3, but I think David answered that in the chat. Paula, I don't know if you have any follow-up.
She's planning to stay muted where she's at, so we'd have to ask for her so Jörg doesn't have to go slogging through the chat pile. The question, what she asked was exactly?
She was noticing that the demo was for ABCD2, and she was wondering about the integration with ABCD3. And David mentioned that the ABCD3 XML is a pretty straightforward integration, but the ontology would be something completely different.
Exactly, because it's not XML anymore, so it's something that would probably look completely different.
I have not really a question, but more like an additional remark, since Deb mentioned that this interface can be used for data quality checks. Precisely for this purpose, there is a dedicated tool developed by the colleagues at the Natural History Museum here in Berlin called BioCASe Monitor. And actually the use case is more like if you have like a consortia of different partners, and they all mobilize data for a specific purpose, and where you have agreed things. Okay, we all want to map the following fields if possible, things like that. Then you can set up an installation of the BioCASe monitor and add all of the different data sources, and can then run certain checks on the mappings and on compatibility, and get some statistics automatically. So this is not really something that's geared toward individual institutions installing it for themselves, but who knows, might be useful. So I will add the link for the software documentation.
Yes, please. So when you say that, yep. Yes, please.
Yeah, I will add the link. The documentation, I think, is not quite up to date, but I know that the colleagues at the Museum for Naturkunde are aware of this and have this on their list to get to. You wanted to ask?
So I thank you for that. I think that it gets at this other question about what are my neighbors doing? How are different collections mapping their data to what fields, and what do they put in those fields? And so a tool like that gives you a way to see, even before you would share your data out, you could check what your other institutions are doing. That's pretty cool.
Very much. Well, I don't see any other questions in the chat. I'm going to stop the recording.